Okay.
So, I've got here a couple of props for this. So,
Like, Mom, I'm a prop.
but anyway, so I got a color wheel, and I got several. And now, what I'm about to do is I'm about to turn it. I am about to turn it on. But first, I want you to predict what color are we going to see. I'm going to give you the option of brown, yellow, or orange. Ready? Let's do it. In this case, we see like brown and orange, but it actually should be yellow. So I'm going to explain why now. All right. So basically, if I'm going to have my ball for this. All right. So the way you see is the sun shoots light at the ball, like, and then it goes reflecting, and it reflects off the ball into our eyes, or it goes or the sun shoots light into the ball, and the ball absorbs that light. We, as you might expect, see what colors are reflected. Now, there is this spectrum called the electromagnetic spectrum, which is just the spectrum of all the colors of light. Red, and the spectrum is of wavelengths of light. For example, red has a longer wavelength than green, has a longer wavelength than blue. And there are actually other wavelengths of light, which I just told, because the electromagnetic spectrum is it's a spectrum, and a spectrum is continuous. But so this ball reflects yellow light, or blue and violet light, or red and green light, anything that mixes to give yellow. But you shouldn't confuse this with mixing on a paid color wheel. The light color wheel is different. Let me just take a moment to explain this. If we've got the primary colors of light, but this is really important. But you might, the primary colors are red, green, and blue, and you might think, well, sorry, this, but they're yellow light. Well, there is actually yellow light, but it is part of the visible spectrum. But the primary colors of light are kind of the primary colors of light. How do I explain this? There is no real primary there are actually no real primary colors of light. All the colors of light are primary. But I don't know if I'm getting off on another tangent, but we use just 3 primary colors. And this is actually how how your computer works. You're getting tricked. You're just seeing red, green, and blue light. You're actually just seeing red, green, and blue light, but your brain just blends the colors to get the colors are so small. If I magnify my screen hard enough, then I should see only red, green, and blue. But it's small, but they're small enough that at this scale I don't see red, green, and blue light. The secondary colors are when you mix red and green, you get yellow. When you mix green and blue, you get cyan. When you mix blue and red, you get magenta. When you mix red, green, and blue all together, you get white. Alright, so that's how light works. Light from the sun gets to an object like this ball, reflects off, and goes into our eyes.
Okay.
I rate this time. I should. I've done actually 2 more takes, but those were not correct takes. So basically, when we spin it, or actually, let me just stick about it first. I call this mind blending. Mind blending. If your brain not only mind blends if events are short and if colors are short enough apart in space, your brain also mind blends if they're short enough apart in time. So basically, if you flick between red and green real fast, you're gonna see yellow. So
because then it's like light mixing, right?
Yeah.
No longer color mixing.
So let's do it.
But this one we've already shown. Should we show the other ones?
And so that means if I set this going, we should see yellow.
Which we don't.
What? I don't know why we don't see yellow. Alright. So now we know it works. Now it's time to play with the other ones. So
this one worked very well, though.
This one worked
especially if you don't look through a camera, but in real life, you actually see cyan.
You see cyan. Actually, let's turn it off. Turning off. Alright, I'm gonna...
Don't bring your face too close.
I'm not bringing it too close. Oh, look! I do see cyan. But it's a very
But in the
dark
camera,
cyan.
it looks bluer. Like, it's real cyan in real life.
Cyan. This one and this one were better than the original one. So... Maybe it's just because there is no real dark. Well, there is, but it's just not that obvious what it is.
The green you used is wrong. This is too dark of a green. Look, it almost looks blue in the camera. And this one should be magenta, right?
Oh, I do see a redder kind of magenta here. And this is real perfect magenta.
And we're gonna try the last one.
Are you gonna try the last one?
I'd like to. Let's pause the video and we'll cut it out and try it. Yeah?
Mm-hmm.
Are you gonna pause it?
Alright, let's do it. So, now what I've got is this thing. Now I've got 3 colors. All 3 primary colors, red, green, and blue. So,
but the green is way too dark.
yeah, the green is way too dark. I don't know why. It's darker in the video. It looks like it's a marker in the video, but here it looks. But in real life, it looks like it's paint. I don't know why.
It's actually watercolors. And look, this is supposed to be what?
This is supposed to be white, but this one failed the hardest. It's kind of gray, but it has to be white.
Wait a sec.
Why am I always getting a darker color than I should?
I think because your greens are too dark. Look, if I go further, then it is sort of like colors of the rainbow, don't you think? Don't bring your hand close to the
I'm
grid.
not.
No, don't. Look at that.
Yeah, I'm seeing colors of the rainbow.
It does look. It does look like a CD, and CD is metallic because it's reflecting all light, all the wavelengths. It does look metallic.
Yeah, let me just. I hit the wrong off button. All right.
Okay. So this was it.
This was it. In fact, that was right. But anyway, the point is there. I'm not. Which is not actually the point. But
you have problem sticking to the point.
Not actually sticking to the point here. Perhaps I will make a separate video about how things are glowing, which will be a separate video because it's really off point here.
Actually emitting light, but this is your favorite topic, actually. How everything emits light and not just reflects it, right?
Yeah.
But this is outside the visible spectrum, so we decided not to put it in this video.
Yeah. In a separate video, we will talk about other spectrums of light that are invisible, and how everything is glowing.
Okay.
See you there.
Bye.